everybody. So today we are going to be going over yet another myth or legend in the knowledge graph or semantic space. And this is a series that I recently started. I'm going to be continuing this as a playlist, so it's going to be linked down below if you're interested in seeing what else comes out that we're going to bust or prove out. That's not actually that much of a myth, but it is more of a legend. Legends can be good or bad. But today we are going to be talking about the zero hallucinations myth. Is it possible to make AI 0% with hallucinations? No chance of a hallucination. So perfect and responsible that there's no way that it can give you any kind of hallucination. Is it possible? Well, let's go into what this means when you're talking about AI models and what you can do to get closer to a scenario where hallucinations are not as much of a problem. And we're going to talk about that. And yes, knowledge graph is a part of it. If you have lived under a rock, or maybe you're just getting new into this space, neurosymbolic AI is a really big deal now. Lots of people are saying that 2026 is the year of the graph or the year of the ontologist. Although we've had a few of those recently over the last few years anyways. So what we're going to be seeing is a lot of knowledge graphs showing up when people are trying to reduce hallucinations. If you haven't seen my video on fact verifying or fact checking AI, I will link it down below so you can go and check that out, because I go actually through the entire process on how you can use knowledge graphs to reduce hallucinations. So let's go over generally how transformer models work, because that's where a lot of the statistical stuff comes into play. When you are dealing with something that's pre-trained, it's learning from all of the examples on the open web and a lot of licensed materials as well on what words come after other words traditionally and in volume across all of the other examples that it can find from its pre-trained models. So when somebody asks, I love cats, and what's the next thing a lot of people say? Dogs, because cats and dogs are the most popular domesticated pets in a typical household globally. We know this because lots and lots and lots of words on the internet say cat and dog in sequence. So it's kind of like ad libs back in the 90s. If you're a 90s kid, raise your hand. Hello. This is where you would fill in the blank, fill in with an adjective, fill in with whatever. That's basically what the AI is doing. So when it's filling in the blank, it has to choose what to fill it in with. And from that pre-training, it's going to select what is the most probable. So let's look at one of the most popular things that people talk about when it comes to probability, and that is winning the lottery. So usually when you hear people talk about this, they say, oh, 1 in a million, 1 in a trillion, 1 in whatever. The one is you, right? You and your ticket is going to win amongst all the other people that are also playing the lottery for that day, or those numbers, or whatever. Clearly I don't play the lottery. But if I did, this is what I would be thinking of, right? Like, what is the chance, the probability of me and my numbers and my ticket being able to get the right sequence or be picked out of the bucket or whatever the lottery does. And it's what is the probability of me in the one amongst all of them. And so that's a low probability, right? It's a very low chance that I'm going to get it amongst everybody else. Now, when you're talking about zero, it is not necessarily 0.00000. Usually in statistics, if you have an extremely low probability, it still has a chance, right? There is a 1 in a million. You still have the one chance. If you have something that is so astronomically improbable, there is still one chance. So it can still be 0.000000001%. There is always a slight, even insignificant chance that something is going to happen. So just talking about statistics, there is no way you can say you have zero hallucinations. And why is that? Because there's always a chance that the AI just doesn't have enough information. It's going to pick wrong. Maybe there's a lot of things that are ambiguous about whatever it is you're asking for. And then there's the very, very high probability that it has wrong information. There's plenty of incorrect stuff out there on the open web. And even if you're dealing with internal data, you're like, no, my internal data, it's perfect, it's pristine, it's beautiful. Said nobody. You can have stuff in there that's wrong. And so there's always a chance. So having zero hallucinations is a fallacy. However, there are ways to mitigate it. And so I mentioned early on in this video, there are ways that you can use symbolic AI, where you have a knowledge graph where that information is stored that you want to be incredibly accurate. Accurate is still ambiguous a little bit here because even knowledge graphs have incorrect data in them, right? But you can verify what's in the knowledge graph. And unlike using table data, which you can do that to force into RAG what you want the AI to consult, basically when it's generating something. And you are lowering the probability of hallucinations because you're giving more trusted information to the AI to consult instead of it just using whatever it knows and the probabilities around that. But when you use a knowledge graph, there is something very unique inside of specifically an ontology-based or something that has constraints in it. So while ontologies are purpose-built to have constraints associated with them, meaning there's cardinality, there's rules around domain and what attributes can be associated with individual domains, that sort of thing, kind of like constrains what data can live and reside amongst that information. So you can't have innings run in a soccer game. That's not logical. And if you structure your ontology with those constraints, then you have some logic checks in there or inferencing. You can also do that outside of an ontology, by the way. You can have these rules as part of checks in, some kind of data quality modeling that you have, something like that. But you can do that, but ontologies are built for that specific purpose. So that's why a lot of people use that instead of like building something custom made or something like that. So just an FYI. But when you have that inferencing, that logic check, where those constraints are telling you this data actually is constrained and adheres to the governance within my model, then you have a higher chance of it being accurate rather than, it's some random information that we have from our data, which means it has a higher chance of being accurate because it's the data you make at your company. But when's the last time you looked at it? And do you have the time and the resources to look at it? So that's where a knowledge graph can really help when you're using that knowledge graph data inside of your RAG operation, which is symbolic AI, where you're using the knowledge graph to either train or ground or whatever it is that you're using the ontology and the knowledge graph data with your AI. That's where you can really, really reduce hallucinations. The other way you can reduce hallucination is don't use generative AI because then you're not using a transformer model. Now, that's not to say that you can't get incorrect things happening with more traditional machine learning models, which, by the way, generative AI is a type of AI. Machine learning is a type of AI, but I have a whole different video on that. If you want it, I'll link it down below. But if you're using a supervised model, you are specifically saying, hey, machine, here's what I define this thing as. When you see that behavior out in the wild, do that. So simple example of this is auto classification. If you see a thing that meows, it has whiskers, its name is Garfield, and it lives in my house, that label of those characteristics is called a cat. So anytime, machine, you see those characteristics out in my images, in, whatever I'm storing all of my pictures on, label that as pictures of cat. Cool, great. I can now, as a human, go in and check the work and say, yep, you, machine, understood the prompt. I said, these are the characteristics, you identified those accurately. But what if it sees an image of a tiger and it's like, oh, the same characteristics, but it's not in my house. At least I hope I don't have a tiger in my house. Or maybe there's a picture of a tiger in my house. And then I can go in, because it's supervised, and correct the logic of how those things are being classified in my image collection. So when you're having supervised learning, or when you are doing that is prescriptive or rule-based, these are things that you say, if you see this, then you do that. That is something that you're in control of completely. And that also means you have to account for every single iteration, every single example, every single characteristic that could possibly ever show up that means cat. So it is kind of hard. And that's why so many people are turning to generative AI, because it kind of helps you with all those different permutations. But that's where you do get some hallucinations, because, with ease, with giving over a lot of the autonomy, instead of you dictating the thing, you are allowing the AI to dictate some of it, meaning you are giving away some of your control and your autonomy on something. You're opening yourself up for more hallucinations and risk. So that just goes with the territory. But it is saying, if you want to have absolutely no hallucinations, which is specifically where the AI is making something up because it needs to fill in the blank, or it is, putting something in that has a lower probability than what you actually want, which, again, you can control those things in an AI with temperature control and, more prompting that, dictates what's allowed, what's not allowed, that sort of thing. There's mitigation tactics within the generative AI space. But sometimes you need to ask yourself, is generative AI the right AI? Because if you really want zero hallucinations, generative AI is probably not the type of AI you want to use. So that is my hot take. Hot takes with Ashleigh on what is the deal with claiming zero hallucinations. There's a lot of ways around that. There's a lot of ways to mitigate even generative AI, but it's not possible with a statistical model to have 0%. 0% means there is absolutely no chance, which means it doesn't exist. So why does it belong in the model at all, right? So this is just one of the many legends and myths they're going to cover in this series. I hope this has at least been interesting. And if there are other myths and legends and things that you would like me to tackle in this series, make sure you comment down below. And otherwise, I hope you have a lovely Thanksgiving if you were celebrating that in America. And if not, I hope you have a lovely week anyways. And with that, I want to thank you very much, and I'll catch you next time.